Good morning, Stella. Welcome back. Last time we saw how to integrate. We're basically at this stage. We saw this one, how to integrate h of x on ax plus b, where the degree of h of x was greater than or equals to the degree of ax plus b. So here we basically said that we are to do the long division of this by this first of all, and then proceed to integration using the different previously seen techniques of integration. We saw this other one where when the degree of this is less than this, there was no need of doing this, but I introduced this just to see to which extent you can reason. So we saw here that this is simply identical to this case, this first case is simply identical to this first case because the degree of ax plus b, the highest power of x here is 1. So if this has to have a degree less than that of this, necessarily the degree of this must be 0, and if the degree of this is 0, that is the highest power of x is 0, it necessarily means this is a constant. So it will be the same thing as integrating this. So and we ended up with this last one where we're integrating h of x on ax plus b to the n. So basically we said that there are two conditions here. If the degree of h of x is greater than or equals to the degree of ax plus b to the n, we proceed to the long division of what? This by this. You understand? Proceed to the long division of this by this. If the degree of h of x is less than the degree of ax plus b to the n, then we first express this in partial fraction before integrating. You understand? So let's dive into some examples for you to better understand what I was saying. So exercises. These are the exercises we are going to do. These are the exercises we are going to do. So I'm just going to choose some of the exercises and you shall be left with the other ones where you are going to exercise yourself. So I'll do I'll do question one. I'll do question I'll do this in fact I'll do this fourth one, and let's say this fifth one. Okay, that's what I'll do. You do the rest. Okay, let's take the first one, the integral of x plus 1 all over 3x plus 1 dx. Let's go into solving sheet. Let me create some more papers. 38. Okay. Okay. That's exercise. How much? Okay, we are into exercises. The first one, we are to integrate exercises on type 3. C, G, and E. Okay, we are to integrate x plus 1 all over 3x plus 1 dx. All over 3 all over 3x plus 1 with respect to x. Okay, we first of all we basically see that this is already in the form h of x on what? Ax plus b, where this is a linear function, this is a polynomial. Okay, now what do we notice? We notice that the degree of x, so the first thing, the degree of x plus 1 is equals to what? 1, because the highest power of x here is 1. The degree of 3x plus 1 is equals to 1. So we notice that this implies the degree of what? X plus 1 is equals to the degree of 3x plus 1. You understand? So whenever we are in such a situation, this is whenever we are in such a situation, what are we supposed to do? When the degree of the numerator of this is greater than or equals to the degree of the denominator, this linear function, what do? We proceed to long division. So since the degree oh wait a minute since the degree of x plus 1 is equals to the degree of 3x plus 1, let's proceed to Euclidean division first. Okay, let's do our Euclidean division. So I will have here x plus 1 and here I have 3x plus 1. Okay, x divided by 3, x divided by 3x, x divided by 3x basically is 1/3. So I will have here 1/3 times this will make x. 1/3 times this will give plus 1/3. So I'm going to subtract, the x will go and I will be left here with 1 minus 1/3 is 2 on 3. That's 2 on 3. Okay, okay, that's 2 on the 3. That's it now. So we are to stop here because there is no more an x under here. So basically I'll write back as I said. This implies x plus 1 all over 3x plus 1 will be what? Will be equals to what? Will be equals to the quotient 1/3 plus what? Plus the remainder 2 on 3 all over what? The divisor. So 3x plus 1. That's it. So this implies x plus 1 all over 3x plus 1 will be equals to 1/3 plus what? 2 on the 3 into 3x plus 1. Okay, so this implies the integral of x plus 1 all over 3x plus 1 dx will be equals to what? The integral of all of this. So the integral of 1/3 plus 2 all over 3 into 3x plus 1 all that dx. So this will be equals to the integral 1/3 integral of dx plus what? I'll bring this 2 on 3 outside. 2 on 3 integral of what? 1 all over 3x plus 1 dx. Is that okay? Okay, now when I integrate this, this is simply x. This will give me x on 3 plus. When I integrate this, how do I integrate this? I'm in a case where I'm to integrate 1 on ax plus b. To integrate this will simply be equals to 2 on 3 times what? 1 all over what? 3x plus 1 prime ln of the absolute value of what? 3x plus 1, and don't forget plus our constant of integration k belonging to the set of real numbers. Okay, this when I rearrange back things, so the integral of x plus 1 all over 3x plus 1 dx will be equals to what? X on 3 plus, when I differentiate this will give 3. So this will give 3. So this times this gives 9. 2 on 9 ln of the absolute value of 3x plus 1 plus our constant of integration. That's the integral. So you see how things are very simple. So you just need to master each of the cases that are being given. Master what is the approach you have to, what's the technique you have to apply whenever you face or you encounter a type of integral. So it's very simple. So let's move to the next question. Let me look at the next. I said we shall do question 4. Okay, question 4. The integral of 2x squared all over the integral of 2x squared all over 2x plus 1. 2x squared all over 2x plus 1 dx. Okay, we basically see that this integral is in the form h of x all over what? All over ax plus b. Now, that's the first thing which we can notice. Now, we see that the degree of 2x squared is equals to 2. The degree and the degree of what? 2x plus 1 is equals to 1. The highest power of x here is 1. Okay, since the degree of 2x squared, since the degree of 2x squared is greater than the degree of 2x plus 1, let's proceed to Euclidean division. To Euclidean division first. Okay, we shall do our Euclidean division. So we are to divide 2x squared by 2x. So let me draw it. I have 2x squared here, and I have what's this? 2x plus 1. Okay, 2x plus 1. So 2x squared divided by 2x squared divided by 2x. 2x squared divided by 2x. The x here goes here, it remains 1x, 2. So the answer is what? The answer is simply x. Yes, the answer is simply x. So x times this gives 2x squared. This x times this will give plus x. So when I subtract, this 2x squared goes, and there is a 0 here. 0 minus x, this will give minus x. Now, minus x divided by 2x, minus x divided by 2x, the x goes, and we are left with minus a half. Minus a half. Minus a half times this will give minus x, and minus a half times this will give minus a half. So when I subtract, the x goes, and I'm left with a half. So this implies 2x squared on 2x plus 1 will be equals to the quotient x minus a half plus what? Plus the remainder all over what? The divisor, 2x plus 1. Is that okay? So let me rearrange things. This implies 2x squared on 2x plus 1 will be equals to what? Will be equals to x minus a half plus 1 all over what? 2 into 2x plus 1. Okay, now that everything is already simple, we can now integrate. This implies the integral of 2x squared all over 2x plus 1 dx will be equals to what? The integral of all this. So the integral of x dx minus a half integral of dx plus a half integral of what? 1 all over 2x plus 1 dx. I hope everything is okay. Now, the integral of this is simply x squared on 2. This will be x squared on 2. The integral of this is simply x, so minus x on 2 plus a half times what? How do I integrate this? This is simply the integral of 1 all over ax plus b. So this will give 1 all over 2x plus 1 prime ln of the absolute value of what? 2x plus 1 plus our constant of integration. So this will be equals to x squared on 2 minus x on 2. When I differentiate this, I will have 2. So this will give plus 1 on 4 ln of the absolute value of 2x plus 1 plus our constant of integration. So it implies the integral of 2x squared on the 2x plus 1 dx will be equals to what? I can factorize a half here. So this will give a half into x squared minus x plus a half ln of the absolute value of 2x plus 1, all that plus our constant of integration. So that's our answer. So I hope everything is clear. I hope everything is clear. So let's move to the last exercise. Let's move to the last exercise. Let's move to the last exercise, which is this integral. Integral of 2x plus 3 all over x plus 1 all squared dx. So question 5, integral of 2x plus 3 all over x plus 1 squared all over x plus 1 squared dx. Okay, the first thing we have to observe is that we see that this is in the form h of x on ax plus b to the n. That's the first observation we can do. Now, how is the power of this denominator, this numerator and this denominator? We know that the degree of 2x plus 3 is simply equals to 1. The degree of what? X plus 1 square. The degree of this will necessarily, the highest power of x, if you are to develop it, the highest power of x will always be what is at the top here. So if I have, for example, ax plus b to the n, the highest power of x will always be, if this n is a, if I would say, is a positive, is a natural number different from 0. The highest power of x, if you are to develop this where n is a natural number different from 0, the highest power of x, will always be what? This n. Even if it is equal to 0, the highest power of x will still be the n. You understand? So the degree of this will simply be equals to what? 2. If I develop this, the highest power of x will be 2. Now, we see that since the degree of x plus 1 squared is how? No, let me write back this. since the degree of 2x plus 3, that is our h of x, is less than the degree of x plus 1 square, what do? We simply express first of all what these in partial fractions. You understand? And yes, we simply express this in partial fraction. You understand? Okay. And there's something I also wanted to say. I wanted to say something. No, it's okay. It's okay. So since the degree of this is less than this, let's first express 2x plus 3 on the x plus 1 square in partial fractions. Okay, so let's do that. Okay, we are to express this in partial fraction. We see that 2x plus 3 all over x plus 1 square. We see that we are in a situation where this bottom, how is this bottom? This bottom is a linear factor, a repeated linear factor. This is a repeated linear factor. So to express this in partial fraction, this will simply be equals to what? A on x plus 1 plus b on x plus 1 square. So in partial fraction, this will simply be written as, this can simply be written as this. Okay, let's proceed. Let's continue with the calculation. So I will just I will just multiply all through. You can just in fact you just express it in partial fraction as you used to do. So here I will have so this 2x plus 3 all over x plus 1 square will be identical to, so the LCM here will be x plus 1 square, this divided by this, will go x plus 1 time, and I will have a into x plus 1 plus this divided by this, I will have b. So basically you see that the numerator and the the denominators are identical here. So this implies necessarily for this to be identical to this, if the numerators are already identical, it necessarily means this has to be equal to what? This. So 2x plus 3 must be identical to what? A into x plus 1 plus b. Okay, there are two ways of proceeding here. The first approach is that you can decide, you develop this other side and you equate like terms to have a system of equations. You understand? You equate like terms to have a system of equations. The second approach is that to easily deduce the value of I can easily deduce here the value of b, and then I'll come back and substitute that b, then deduce the value of a. How can I deduce the value of a? I know that if x here is equals to -1, all of this becomes 0, and b will be identical to what? I'll also substitute -1 here, and I'll have the corresponding answer for b. So that's how I will proceed. So when x equals to, when I equate this to 0, x will be equals to what? -1. So when x is equals to -1, we basically have what? 2 into -1 plus 3 being equals to what? I'll have a into, when I substitute -1 here, this becomes 0 plus b. So this implies our b is equals to what? Our b is simply equals to this is 3 minus 2, so our b is equals to 1. So I'll take this b, come and substitute it back here, and from there I will deduce this thing, the value of a. Or instead, you can just develop this. You know that. Wait, let me continue in the next page. Question 30, page 37. So I have 2x plus 3 being identical to what? A into x plus 1 plus b. Okay, what I will do is that I will develop this. So this 2x plus 3 will be identical to what? Will be identical to ax plus a, because when I develop this, this is a times x plus a times 1. Okay, now we had already the answer of b up there, so this will become plus, our b was what? 1. So this implies 2x plus 3 must be identical to what? Ax plus a plus 1. So we then equate, if I would say like terms, these are terms in x. When I equate this to this, if I equate this to this, so like terms, so I will have these systems of equation. I have a directly being equals to what? This a will be equals to what? This 2. I also have a plus 1 being equals to what? 3. So you basically, this is equation 1, equation 2. So you basically see in all of the cases, here you have already a equals to 2. From this, you also have what? A equals to 2. So we have already our a and b. So our 2x plus 3 all over x plus 1 square is equals to what in partial fraction? Is equals to our a is 2 all over x plus 1. Our b is 1 plus 1 all over what? X plus 1 square. When we have already done this, we can easily integrate them. So this implies the integral of 2x plus 3 all over x plus 1 square dx will be equals to what? 2 into the integral of 1 all over x plus 1 dx plus the integral of 1 all over x plus 1 square dx. Is that okay? Okay, this will be equals to 2. How do I integrate this? This is simply the integral of 1 all over ax plus b. So this will be equals to times 1 all over x plus 1 prime ln of the absolute value of what? X plus 1 plus, how do I integrate this? I'll first write back this. Notice that this can be written back. This is the integral. I'll write back, wait, I'll write back this as the integral of x plus 1 to the minus 2 dx. So it's like you are basically integrating ax plus b to the what? To the n dx. You understand? So how do you integrate this? This will simply be equals to 1 all over what? Ax plus b. Oh, I made an error. This will simply be equals to 1 all over what? X plus 1 prime times what? This x plus 1 to the minus 2 plus 1 all over what? Minus 2 plus 1 plus our constant of integration. Is that okay? So this will be equals to, when I differentiate this, I have 1. So this is 2 ln of the absolute value of x plus 1. When I differentiate this, I have 1. This minus 2 plus this will give me minus 1. So I'll also have minus 1 here. So this will be equals to minus 1 all over what? X plus 1 plus our constant of integration. So the integral of 2x plus 3 all over x plus 1 square will be equals to this. So you basically see how integrating such a thing is very simple. There's nothing complicated in it. K belongs to R. So it's very simple to integrate this. So we basically saw uh, exercises on how to integrate such forms. This, I told you that this will be the same thing as this, because the degree of this is 1, so necessarily the degree of this, if it is less than this, it must be equals to 0, and as such this must be a constant. You understand? So this will be the same as integrating this. So we basically saw exercises where we had this situation and what this situation. So you will do the other exercises, that is question 2, question 3. Let me add a last exercise. You're going to try, let's say, the integral of 4x plus 5 all over, let's say, all over x plus 2 cube. You're going to try this. So, just exercise yourself. After doing all of these exercises, you can also go to your textbook. You try to find more exercises for you to really master how to integrate such functions. So that was all for this video. See you in the next video, where we shall continue with the integration of fractions, and we shall see the next integration of fractions of rational functions, where we shall see the next subtypes. See you in the next video.